Ocean currents and circulation. Ocean currents and circulation refer to the large-scale movement of seawater in the world's oceans, driven by various factors such as wind patterns, the Earth's rotation, temperature differences, and salinity variations. These currents play a crucial role in regulating climate, distributing heat, nutrients, and gases, and influencing marine life and ecosystems. Here's an overview of ocean currents and circulation. Surface currents. Surface currents are the horizontal movement of seawater at the ocean's surface, primarily influenced by wind patterns and the Earth's rotation, Coriolis effect. These currents help distribute heat around the globe, playing a critical role in regulating regional climates. Wind-driven surface currents. Winds blowing across the ocean's surface push the water, creating currents. The direction of the wind, along with the Coriolis effect, influences the movement of water. These currents flow along the boundaries of ocean basins, forming large circular patterns called gyres. Gyres. These are large, circular ocean current systems found in each of the major ocean basins: Atlantic, Pacific, Indian. The 5 major gyres are North Atlantic Gyre, South Atlantic Gyre, North Pacific Gyre, South Pacific Gyre, Indian Ocean Gyre. The gyres rotate clockwise in the northern hemisphere and counterclockwise in the southern hemisphere, a result of the Coriolis effect. Deep ocean currents, thermohaline circulation. Deep ocean currents, or thermohaline circulation, are driven by differences in water temperature and salinity, which affect water density. These currents move water slowly through the ocean's deep layers, and they play a vital role in global climate by redistributing heat and influencing atmospheric circulation. Temperature and salinity. Cold water is denser than warm water, and salty water is denser than fresh water. As cold, salty water sinks in polar regions, it pulls warmer surface water in to replace it. This process helps drive a global conveyor belt of ocean circulation, known as the Global Conveyor Belt or Meridional Overturning Circulation, MOC. Global Conveyor Belt. This is a complex system of deep water currents that flow through the world's oceans, distributing heat and regulating climate. For example, warm surface waters from the equator move toward the poles, where they cool, sink, and flow back toward the equator. Factors influencing ocean currents. Several factors influence the movement of ocean currents. Wind. Surface winds drive surface currents and contribute to the formation of gyres. Earth's rotation. The Coriolis effect, due to the rotation of the Earth, causes currents to move to the right in the northern hemisphere and to the left in the southern hemisphere, influencing the direction of currents. Temperature. Warm water at the equator tends to move toward the poles, while cold water moves from the poles toward the equator. Salinity. Changes in the salinity of water affect its density, which in turn influences how currents flow. Tides. The gravitational pull of the moon and sun causes tidal movements in the ocean, which can also influence local currents. Upwelling and downwelling. Upwelling. This occurs when deep, cold, nutrient-rich water rises to the surface. Upwelling zones, such as along the coasts of continents, support high biological productivity, making them important for marine ecosystems and fisheries. Downwelling. The opposite process, downwelling, happens when surface water sinks, often due to changes in water density caused by cooling or increased salinity. Importance of ocean circulation. Climate regulation. Ocean currents redistribute heat from the equator to the poles, helping moderate temperatures and regulating weather patterns. For example, the Gulf Stream carries warm water from the Gulf of Mexico to the North Atlantic, contributing to mild temperatures in Western Europe. Nutrient distribution. Ocean currents play a role in nutrient cycling by bringing nutrients from the deep ocean to the surface, upwelling, which supports marine life. Global climate change. Changes in ocean circulation, particularly in the thermohaline circulation, can have significant impacts on global climate, including shifting weather patterns, sea level rise, and temperature changes. Notable ocean currents. Gulf Stream, a warm surface current in the North Atlantic that significantly affects the climate of North America and Europe. El Niño and La Niña. These are large-scale climate phenomena related to the periodic warming, El Niño, or cooling, La Niña, of surface waters in the central and eastern Pacific Ocean, which impact global weather patterns, including storms, droughts, and temperature shifts. The Kuroshio Current, a warm ocean current flowing northward along the eastern coast of Asia, influencing the climate of Japan and other East Asian countries. Impact on marine ecosystems. Ocean currents influence marine ecosystems by regulating the distribution of nutrients, oxygen, and temperature, which are critical for the survival of marine life. Currents also affect the migration patterns of marine animals such as whales, turtles, and fish. Conclusion. Ocean currents and circulation systems are essential components of Earth's climate system, affecting weather patterns, climate regulation, marine ecosystems, and global heat distribution. Understanding these currents is key to predicting climate change and managing marine resources effectively.